Hey everyone, and welcome. Today, we are going on a pretty wild journey deep inside ourselves. We're going to uncover the fundamental chemistry that literally makes you, you. Think of it as meeting the tiny, essential building blocks that construct your entire world. So, let's just start with a big question. What are you really made of? And I mean, let's forget your personality, your memories, all that stuff for a second. Physically, chemically, what's at your absolute core? Now, you might think the answer has to be ridiculously complex, right? But here's the shocker. It turns out a whopping 96% of your entire body mass boils down to just only four basic elements. That's it. So let's take a closer look at this elemental cocktail. What are these four ingredients that make up almost all of you? And here they are. First up, oxygen, making up a massive 65% of your body mass. It's literally everywhere inside you. Then we have carbon at 18%. This one is the true backbone of life. It's the element that forms all the long, complex chains that everything else gets built on. And rounding it out, we have hydrogen at 10% and a little bit of nitrogen at 3%. These four are the undisputed heavyweights. But of course, these elements aren't just, floating around in a soup. This is where it gets really interesting. They link up, they bond together in these incredible ways to form the four essential molecules that build everything. These are the true building blocks of life. Which brings us right here to life's four building blocks. I kind of like to think of these as the master Lego bricks, the special pieces you use to construct every single part of yourself. All right, so here they are, the big four. You've got carbohydrates, proteins, lipids, and nucleic acids. Remember these names because they are the absolute stars of the show today. So, we have these Lego bricks, but what do they actually do? Let's get into their job descriptions, starting with the first three. We're going to see how they fuel you, build you, and store everything you need to survive. Okay, this chart lays it all out beautifully. So, carbohydrates, the stuff you get from bread, potatoes, sugar, that's your body's go-to for quick energy. It's the fast fuel. Then you have proteins, found in things like meat and eggs. Their job? Building and repairing you. They're the construction crew. And finally, lipids. You probably know them as fats. They're all about storing energy for the long haul and keeping you warm. Three different jobs, all working to keep you going. And let's just zero in on proteins for a second, because they have a secret identity. They aren't just building materials. As this quote points out, many of them are also enzymes. You can think of enzymes as the tiny little factory workers inside you that speed up every single chemical reaction, making life happen at the speed it needs to. Without them, everything would just grind to a halt. All right, so we've covered the fuel, the building materials, and the factory workers. But what about the instructions, the master plan? Who's in charge? Well, that brings us to our final, and you could argue most important, building block, the master blueprint. I mean, think about it. Every living organism on this planet, from the tiniest little bacterium all the way up to you, is operating based on a pre-written code, a set of instructions that tells it exactly how to grow, how to function, and how to make copies of itself. And this iconic, beautiful double helix is that code. It's the blueprint for building you. So this incredible molecule, DNA, along with its partner RNA, belongs to a family called nucleic acids, and they have two critical jobs. First, they store all that genetic information, the blueprint. And second, they use that blueprint to tell the cell how to build all the proteins, which, as we know, go on to control literally every activity inside your cells. They're both the library and the librarian. But hang on, the big four don't do all this work by themselves. No way. They rely on an absolutely essential supporting cast to make all the magic happen. Let's meet the unsung heroes of your body. First, there's water, the stage where basically every single chemical reaction takes place. Then you have minerals, which act like tiny spark plugs for our cells, getting things going. And finally, vitamins, the crucial little helpers that assist in all those biochemical reactions we were talking about. And just to really hammer home how important water is, get this. Roughly 2/3 of your entire body weight is just good old H2O. It really is the solvent of life, the entire environment where everything happens. So that leads to a pretty important question. What happens when the supporting cast, especially the minerals and vitamins, are missing? What happens when these crucial little helpers don't show up for their shift? Well, the consequences are pretty stark, and they're universal across all of life. On the left, you're seeing scurvy in a person, a nasty disease caused by a lack of vitamin C. And on the right, that's a plant suffering because it doesn't have enough potassium. It just goes to show you, without these essential helpers, the whole system starts to break down, whether you're a human or a houseplant. Okay, so we've met the elements, we've met the building blocks, and we've met the supporting cast. Now let's pull the camera all the way back and see how this all comes together in what you could call the symphony inside you. Because that's the truly amazing part, isn't it? None of these things, the carbon, the proteins, the water, they don't work alone. They are a perfectly coordinated, incredibly complex orchestra, and every single second of every single day, they are working in perfect harmony to play the symphony that is you. And this brings it all right back to your daily life, to the choices you make. Every bite of food you take, every meal you eat, is providing the notes and the instruments for this internal orchestra. So the next time you sit down to eat, just think about that. You're not just eating, you're conducting. So the real question is, what kind of symphony will you choose to compose?